If I could remember that example I gave Hari Har. Let's say on one of these problems you had the wrong angle. Instead of having, if I can find it, and it's on one of the other problems we did for homework. Let's see. Let's go back here. And it might not be one of these problems. It might be one that we did. Yeah, let me go here. Let me go right here. And this, now see, I'm really hanging myself out here because I have to be able to remember this, right? But if I don't remember it, Hari Har's got my example of what I showed him, so you could always go back to him and say, show me that piece of paper. So let's say on this problem right here, you didn't make that the sine and cosine of 40, okay? For whatever reason, you didn't get that number right. But it shows up here and here, okay? I will take off a half a point here and a half a point here, not the whole point, because my way of thinking is you at least put something there. You put an angle, you knew to put the angle, but you got the wrong angle. So you knew the methodology to put the right number there, but you didn't know the methodology how to get the angle necessarily. You screwed that up. But you didn't screw the whole thing up. So therefore, if you put your work down and show me and make it legible, right? That was part of the thing I talked about last class. I can help you. I can show you that, yep, you got the right method, you just screwed up on your angle. Or like the other day when I screwed up, I had the right angle figured and then I went down and put the wrong number and used the wrong number. Well, see, I would have rather Al didn't take all the credit off for that. I would only want him to spank me just a little bit, not the whole amount. Okay? So that's how I'll do the grading. I think that's fair. I think that's about as fair as I can be. And if you can come up with a different system that maybe would suit me to be more fair, then But that takes all the subjectiveness out of it, I think. It's very objective. Okay? It's kind of like a true-false question, almost. Kind of, but better. Because even if you got the wrong answer, you get half the points. So, but the idea is for you to do well. Okay? If you can show me that you pretty much got the right answer, or you got the right techniques, just the wrong final solution. Why isn't that? There we go. Then we can work together on that. And here's the problem that really that's going to show up. Okay, this is where that really shows up. Now I gotta go back here and remember how to do that lasso trick. What? Come on. Work with me. Huh. Okay. Guess that'll work. And actually, we want to move this up, don't we? Give ourselves some room. Okay. Is this one of the... Was this one of the homework problem?
Yeah.
Well.
I got it wrong.
Oh, no. Are we okay on that last example? What I showed you? Does that kind of make sense? You just need to practice it now, right? Okay. Yeah, we're getting close to noon, aren't we? Ooh. On this problem, and this is, that's out there for you now, right? Okay. On that problem, the key is drawing the right picture. So, and I've got this picture here, but basically what you want to do is you want to draw a line right here, because then that tells you that this angle right here is 50 degrees, doesn't it? Because this line's parallel to this line, So those two angles have to be the same, right? Which means that this angle right here is 20 degrees. That's kind of like what we like to see, isn't it? Because based on what we've been doing so far, all of our forces are relative to the x-axis. So we would end up with two kips at 20 degrees, wouldn't we? And I'm going to kind of hurry through this so we can do a couple more other things. So that we take care of. Then we have to, I am doing the right problem, aren't I? 323. I got to make sure. 324? Yeah, I said 323. Well, that's on this same page. But as you can see, 323 and 324 are both on that same page, so there's not a whole lot of tough stuff there. Let's see. So on that problem, so we've got that, and all we need to do then is what? We get our cursor here. We end up with a force right here that is 2 kips sine of 20, and a force, if you will, right here, which is 2 kips cosine of 20, right? Well, we know this to be 3, so what we're looking for is this x distance and this y distance. Correct? Well, and see, me being a simpleton like I am, I draw a little triangle here. And I know this is 3, which is the hypotenuse, right? And I know this angle to be 50 degrees, right? And I need to know this is the side adjacent, right? And this is the side opposite of the angle. Well, see, me being me, I know that opposite over hypotenuse equals what? The sine of 50, right? Well, I know the hypotenuse, so opposite equals the sine of 50 times 3, doesn't it? See, this goes over to the other side and becomes a multiplier then, right? So then I know that sine of 50 times 3 should equal something like 2.29 feet, which ultimately is the y value, isn't it? Then to find the x, well, that's the adjacent. Well, I know the adjacent over the hypotenuse equals the cosine of 50 degrees. Well, the adjacent then is the cosine of 50 times 3. And that equals 1.928 feet. That's the hard part of the problem there. I'm done now. Because I just go in there and do a, well, I guess I would have had to, did I need to do the, yeah, all I'm finding here is the moment, right? For this problem, or do I need the resultant? I may not have done the whole thing. Just says calculate the moment. Okay, so I do the moment about point. Do what? Do what? What?
We only needed the y for the moment.
No. Because look, there is a distance here, and there's a distance here. Both of those forces are this is the force that's acting. Okay? Well, there's an x component and a y component doing something to this. If one of those two were going through the part or through this point, then you wouldn't have to deal with it.
So maybe the other problem that I was doing, it was going through the point, that's why we didn't need it.
No.
I only did the y.
That's why your number didn't come up right.
Yeah.
Yep. So you, let's see, where's my mouse at again? So I do the summation of the moments about A. Okay, Okay, this one right here is making that thing spin counterclockwise, or excuse me, clockwise, right? Negative 2 kips sine of 20 times the x value, 1.928 feet. This one's making it go clockwise as well, right? Minus 2 kips cosine of 20 times 2.298 feet. Do all the math on that. You end up with 5.64 kips feet. It does come up a negative value, so it is clockwise. Yeah, you have to, in this case, Al, you have to account for both, if I can find my cursor again, you have to account for both the X and the Y breakout of that force. Okay? Because, and think of it in terms of, if you had your hand on that wrench and you weren't pushing perpendicular to that wrench, some of the force is actually pulling the wrench and some of it's making it turn, isn't it? Which is not a good situation. You want it to be perpendicular, but if for some reason your hand was slipping or whatever, you were pulling, you were sliding, not really slipping, but if you were pulling in that direction, you're putting tension on that wrench, then not all of it's going right to turning that bolt. So that's what you have to account for. Okay?